is called a monomial. You can have more than one variable, but you can only have one number, okay? So the number 2 is a monomial. X squared is a monomial because you have what in front of it? A 1, okay? This has 2 different terms, okay? So it is not a monomial. This is a monomial. This is not a monomial. This is a monomial, okay?
So if it has a sign, it's not?
That's correct. Okay. The sum or difference of 2 or more monomials is called a polynomial. A polynomial. Okay? Poly meaning what? More than one, right? Specifically, the sum or difference of 2 monomials is called a binomial. In other words, when you only have 2, it's called a binomial. When you have more than 2, it's called a polynomial. Okay?
Would you get like a week lunch attention or something?
All right. Example 2. Circle the binomials. All right. So x plus y, would that be a binomial? Does it have 2 or more? The sum or difference of 2 or more?
Yes.
It only has 2, so it is a binomial. Remember, it's 2 that's a binomial. Okay? What about this one? 2 terms. Yes. What about this one? 2 terms? No, because when you distribute, you only end up with 1 term, 2x squared times 2y, right? So it would be written 2x squared 2y, and that's not. So, no. What about here?
Yes.
Yes. Okay? So, the sum or difference of 3 monomials is called a trinomial. Circle the trinomials. So that means we have 3 terms with signs between them, different terms. Here we go, right? 1, is that one? Okay, there is that one. Okay, it doesn't have signs between them, does it? So example number 4. Let's do this. So it's giving you, we did this at the beginning of the year, if you remember. So we can only add and subtract like terms. This is an addition problem. So we add 1x squared. I would suggest you put it there. Minus 5x minus 5. And it lines up really pretty, doesn't it?
Maybe 2x squared?
No, it's this one. 2x squared plus 3x plus 2 plus x squared minus 5x minus 5.
Because I thought you were doing the other one.
I'm so sorry. All I'm doing is putting the second one underneath the first one, and then I'm going to add them. So here I end up with 3x squared minus a negative 5 and a positive 3 gives me a negative 2x. A negative 5 and a positive 2 gives me negative 3. Do you also notice that they are listed by degree? Okay, this is a second degree term, this is a first degree term, and this is a 0 degree term because it means that it's x to the 0, which is really what? What is x to the 0? What's the value of x to the 0? What is the value of any number to the 0 power?
0.
1. Right?
Oh, yeah.
Right? Remember we figured that out before? Okay, 5 to the 0 power is 1. Well, x to the 0 power is 1. 1. Okay? No, not x. It's 1. Because no matter what you substitute for x, you're going to end up with a 1. Okay? All right. Here we go. Okay, so let's look at this one. Subtracting. Now, when we subtracted binomials or polynomials, what do you have to remember to do? Do you remember when we did this at the beginning of the year? Anybody remember? What is this negative sign out here due to each of these terms?
Everything, like you times it by a negative
It changes it to the inverse, correct? Because it's like negative 1 times 1 squared. So if we put a plus sign out here and we change all of our signs, negative 1x squared plus 4x minus 1, and then I'm going to go ahead and put my 1 up here. I'm just not rewriting the whole thing. I'm just using the second term, rewriting the second term. Now 2x squared, and when I combine that with negative 1x squared, I get 1x squared. When I have 1x plus 4x, I combine them, I get 5x. When I combine a negative 4 and a negative 1, I get negative 5. Okay? And we did that at the beginning of the year. You guys, I know it's just been a while. Okay? We're going to use these in application issues, and that's where we'll have fun. Find each sum or difference. So here again, all we're going to do is combine our like terms. Okay? So we've got 4 and 6. They've got x squareds and y squared. So we end up with 10x squared y squared. Here, these are both positive, so plus 13xy. Here I have a positive and a negative. So what happens here? It ends up as a 0 pair. Do we write 0 at the end of this? No, we just leave it off. Okay? Now, over here, they've written it in a manner that we've got to change our signs, don't we? So what I do is I'm going to combine, and I'm going to change this, and change this. Okay? So now 11 plus 5 is 16m squared. 2 and 6 is plus 8m. And a negative 11 and a positive 17 gives me a plus 6. It's pretty simple. Okay? So what happens when we don't have all the terms the same? Well, these are combining, so it's an add sign up here, so I'm just going to put a combine sign. I have 4ab. I don't have anything to combine over here, do I? So I'm going to go ahead and line it up here with a positive 4ab, and I have a positive 6b squared, okay? So now when I combine those, what do I get here? I don't add anything to that, so I keep it, correct? So I have 3a squared. A positive 3 and a positive 4 gives me a plus 7ab. And a positive 6 and a negative 1, right, because that 1 is there, gives me a plus 5b squared. Okay? And if you notice, a comes before b, doesn't it? So when you're listing terms, it's very important that you learn that it's by degree and by the alphabet. So in other words, if I had a 3C and a 4A to the fourth, 4A to the fourth would always go before 3C because A comes before C, okay? If I had an A to the fourth is obviously higher, and we will get you a rule sheet for that also soon. The measures of two sides of a triangle are given. P is the perimeter. Find the measure of the third side. Oh, so now we have the perimeter and we have two sides. Now you could attack this two different ways. You could subtract each of these because remember when we add all three sides of any figure we get the perimeter, correct? So the perimeter is the outside edge, but to me it's easier to combine the two sides than only subtract once. Does that make sense to you? Okay, so here I'm going to do this. Plus 1x squared plus 3x minus 5. So that's the two sides. Okay, so I've got 3x squared plus 6x, and then I have plus 1, don't I? Now, to find the third side, all I have to do is come over here, and I'm going to write it this way so that I remember to change all my signs. Subtract parentheses 3x squared plus 6x plus 1, because it's critical for you to change those sides. If you don't, you will get the wrong answer. And what I can do over here then is write, I'm going to combine a negative 3x squared minus 6x plus 1 minus 1. You're right. My bad. Okay. So then I have a 4x squared, and I'm combining it with a negative 3x squared, which leaves me x squared, or 1x squared. I have a 5x and a negative 6, which leaves me negative x. And I have a plus 5 and a minus 1, which leaves me plus 4. Now, if I wanted, that is this side, x squared minus x plus 4, right? And that would be my third side, so I could write that down here, minus x plus 4. If I wanted to double check this, remember we said that if we combine all three of these, we get what? The perimeter, correct? So I have two of them combined already, don't I? So now I could just take this other one and do plus 1x squared minus 1x plus 4, and let's see if it's going to equal my perimeter. So this will be my check, okay? So I've got 3 plus 1, which is 4x squared, 6 minus 1, which is plus 5x, and I've got plus 1 and plus 4, which is plus 5. Well, doesn't the perimeter, didn't they say the perimeter equaled that? So that is correct. I got my answer right. Everybody see that? Anybody have any problems with that? Everybody good? Is that a yes?
Yep.
Even though I'm not awake, it's a yes? Okay.
I got like no sleep last night. I got like
All right.
4 hours.
Here we go. Let the fun begin.
Yay.
Find the area. I've got to get something to drink. Sorry. Just dry mouth, I guess, this morning. All right. Find the area of the shaded region. If 9x squared minus 6xy plus 3y squared is the area of the total region, and 3x squared plus y squared is the area of the unshaded region. So what would we need to do? We know that the total is 9x squared minus 6xy plus 3y squared, right? And we know that what? They also told us that the unshaded region, so this region, is 3x squared plus y squared, didn't they? Okay? So we need to find, they want us to find the unshaded region. So total unshaded. Okay? So what do I need to do?
You need to subtract the unshaded region from the shaded region.
Okay. All right. And I just want to put a note. This is where you see that alpha and by degree is how you list. Okay. You always list your polynomials by alpha and degree. So anyways, x comes before y, right? That's why x squared is before y squared. Do you see that? Okay. All right, so I've got 9x squared minus 6xy plus 3y squared. And you say subtract. I'm going to say combine the opposite, okay? not the inverse. I said that incorrectly before. The inverse is when we flip them, right? Combine the opposite. So I'm going to put a plus, so let's see, 3x squared. So I'm going to put that here, 3x squared. I don't have anything to go with this, do I? Okay, so I am going to put minus 3. Oh, no, not a 3. Just minus how many y squared? Minus 1y squared. And if you notice, I lined them up, so I'm not going to get confused as to what I can combine and what I can't. And 9x squared minus, adding it to a negative 3x squared is 6x squared minus 6xy. And 3y squared, and I am combining that with a negative 1y squared, and I end up with a, what?
Negative, positive 2y squared.
Positive 2y squared. Yeah. So 6x squared minus 6xy plus 2y squared. And if I wanted to do a check, I could just go back and add them together and find out that they equal the total. Okay. All right, find the total area of the figure. What do I have here? I have this area in here, and then I have y squared, y squared, y squared, y squared, don't I?
Would that be 4y squared?
Yep. So, what are we going to combine? It says find the total area. So, 13x squared plus xy plus y squared. And then these 4 are going to add up to plus 4y squared. So the total area is 13x squared plus xy plus 5y squared. Anybody have any questions about that? All right.
You check this one differently.
What?
You have to check this one in a different way.
No, you would just subtract 4y squared from your total, and you should come back to this, right?
Oh yeah.
Okay. All right. And 5 minus 4 would give you 1. Find the area of the shaded region. If the area of the total region is, so I've got a couple of different regions that I'm going to have to add. I'm going to have to subtract from the total region to find the shaded region, correct? So I know that the total region is 5x squared minus 4xy plus 2. They mean the whole enchilada, okay? All right, so if that's the total, and they only want to know the shaded, I got to take these out, don't I? Well, you could subtract them, okay? So, or what are we going to do?
Combine them.
Combine them. If we combined them, I have an x squared plus an xy, don't I? Putting them in alpha and by degree. Okay? Alpha and by degree. So, I need to, what? Do I need to add this to this, or do I need to subtract it? Subtract it. So I'm going to do this just to remind myself what I'm doing. I'm going to come over here and combine, though, when it looks like I'm combining, but I'm going to change my signs, and I'm trying to get some lead out of here. It does not seem to want to work, so let's go on to this pencil, and I am going to subtract, and I'm going to go ahead and put my negative 1x squared, and then I have a positive 1xy, and I would suggest that you put those ones in front of there. And 5 combined with what?
You have to change the
Oh my goodness, I'm just messing up, and good thing you guys are catching me. Okay, 5, and I'm combining it with a negative 1 gives me a 4x squared, and I have a negative 4xy and a negative 1xy, which gives me negative 5xy, and then that's plus 2, And there's my answer. Pretty simple? Yeah. Piece of cake. Okay? All right? So that's all I have for you today. Anybody have any questions? No? Well, good.